All right, guys, here we go. One more review. This is for 3D solids. All right, how many faces? Oh, and again, I'm going to go pretty fast. So if you need to pause, rewind, do what you need to do to try and see where I'm getting the answers that I'm coming up with. So an octagonal pyramid means we've got an octagon on the bottom, and it's extending to an apex vertex at the top. So the number of faces will be the octagon on the bottom plus the 9 triangles. So I'm going to put 10. Edges, there will be 8 for the octagon on the bottom and 8 going up to the apex vertex. So that's 16. Vertices, there will be 8 for the octagon and 1 up top, which means 9. Which means I think I have this off. An octagon, 1 on the bottom plus 8. That's got to be 9 also. That was silly. Awesome. Find the number of vertices, edges, and faces for these crazy shapes here. So the faces, we're just looking at the outside ones. There's 4 triangles plus 4 around plus 1 on the bottom. That's 9 faces. Edges, 4 lateral edges up top, 4 there, 4 and another 4. So 4 times 4 would be 16 edges. Vertices, I got 8 for the prism and 1 up top. I think I got 9 there. Again, if you guys find errors in any of my work, and I'll say the first kid from each class to present an error that I've made on this review, I'll even put my name on it just to own it. That's got to be some points. I'll go ahead and say 10 points added to a homework. So that might help you pay attention. So we got this prism, faces, 6, edges, 12, vertices, 8. Classifying this figure, this is called a cone. The number of vertices, it actually says name the vertices. So the only vertex I have is point M. Edges, if I only have 1 point, then I can't connect that to another point, so I have no edges. All right, and I have 1 base, and that would be circle L. Okay, here I got a pyramid. That base, I believe this is a rectangular pyramid. The vertices, I have points P, Q, R, S, and the apex one up top. Edges, I got P, Q, Q, R, R, S, S, P, P, N, Q, N, R, N, S, N. Should be 8 of those. Bases, I only got 1. That is going to be this rectangle or this parallelogram, whatever that base is, P, Q, R, S. All right, here's nets, and I got to be able to put them together. Describe the 3-dimensional figure. Well, this, if I put it back together, would be a cylinder. All right, this, I'm going to go ahead and say that's a square pyramid. I guess you could say I'm assuming some stuff. If you said rectangular pyramid, you'd be just fine there as well. Page 1. Done. Let's keep this going. All right, now we get to a real problem. Surface area. If we have a composite figure, you better have a dang plan. So these are, I'm looking at 2 square pyramids. So realistically, I'm going to find, I could paint the 4 triangles up top, and I got 4 triangles on bottom. So 4 times 1/2 of the base of each, which is 8, times the height of that triangle is 30. The base of the bottom triangles, each of the bases is 8, and the height of those are 20. So plan, and I went after it. Now, if you wanted to do the surface area of each, you got to get rid of the base, though, because we can't paint the base. That is being covered. So 4 times 1/2 times 8 times 30 plus 4 times 1/2 times 8 times 20. I should have a surface area of 800. Now these are feet. This is an area, two-dimensional square feet. Now here, I need the lateral area of the cone because I don't want the base, can't paint the base. And I'm going to double that because I got this lateral area here and lateral area down here. And then I need the lateral area of the cylinder because the bases are still covered. I don't want the bases. Remember, lateral area is everything except for the base. So to find the lateral area of a cone, that is pi times the radius times the slant height. Lateral area of a cylinder is 2 pi r h. So my plan is now converted into a formula. So I'm going to do 2 times pi times the radius, which is 8, times the slant height, which is 12, plus 2 times pi times the radius times the height of the cylinder, which is 16. I'm going to leave my answer in terms of pi. I got 96 times 2, which is 192 pi. 8 times 16 is, I think it's 128. Let me just make sure. 8 times 16, 128 times 2. So I got 256 pi. And if I add those up, I got 448 pi meters squared. Again, I'm going fast. If you find an error in my work, it's going to be in your best interest to let me know. Okay, volume of a prism. I'm going to need to find the area. Volume of a prism is area of the base times the height. But this is tricky. The base is actually the pentagon. So I got to do 1/2 AP times height. Well, let's see how much of that information I got. Ooh, they actually gave me the apothem. That's nice. Then I need the perimeter. Well, this is 8 times 5. The perimeter would be 40. So I got the area of the base, and the height is the distance from one base to the other, which is 15. So I got, if I multiply all that together, I'm getting 1,650 centimeters cubed because this is a volume, three-dimensional. Volume of the cylinder. Game has not changed. Area of the base times the height. All right, these are volume ideas. Well, the area of the base here is going to be pi r squared times height. So the radius is not 15. It's going to be half of that, 7.5. And the perpendicular height is what I was looking for, is 16. So 7.5 squared times 16 means I got 900 pi inches cubed. Okay, we've got to keep going with volume here. I got a hexagonal pyramid, and they've already told me the area of the base. So again, volume is area of the base. Ooh, it's a pyramid, so I want actually 1/3 of that. But I already know the area of the base. I'm going to do 1/3 times the area of the base times the height, which is 8. I had everything I need. Okay, so 1/3 of 50. Sorry. Calculator helps me out here. I got 112 cubic meters. Because again, we're going after volume. Cone. Again, volume of a cone is 1/3 area of the base times the height. The area of the base is going to be pi r squared. And my radius, the diameter is 12, so my radius is 6. And the height is 10. I can't forget to square that radius. So 1 divided by 3 times 6 squared times 10. I got 120 pi centimeters cubed. Again, we're at a cone, 1/3, area of the base times the height. They've told me the area of the base is 16 pi feet squared, and the height is 9. 1/3 of 9 is 3. 3 times 16 is 48 pi cubic feet. 2 pages down. Now this one, make sure this is a difficult one. Make sure you understand this is a cylinder where a cone has been removed. Okay? So it's just going to be the volume of the cylinder, which is the area of the base times the height, minus the cone, which is 1/3, area of the base times the height. And I got all that, the information I need. The radius is 8. The height is 12. Radius is 8 also for the cone, and the height is also 12. All right. So, calculator time. Again, I'm getting 512 pi cubic feet. Surface area. Here's where the problems get more difficult. This is a tough problem. Surface area. I'm going to handle this. I'm going to do 2 hexagons plus 6 rectangles. The hexagons, the formula is 1/2 AP. Well, 2 times 1/2 means all I need is AP. And then I'm going to have to do 6 times base times height. So the apothem would be this measure here. Got to use this crazy triangle here. I know the bottom of this is 4. So I need to know the apothem if the bottom of this triangle is 4. Since this is a hexagon, there will be 12 of these triangles in there. 360 divided by 12 means this angle here is 30 degrees. That's actually a special right triangle. I could do a trig problem, but I can go faster with special right triangles. I know my apothem is 4 square root of 3. The perimeter would be 8 times 6, which is 48. And then I got 6 congruent rectangles. The base of all those rectangles is 8. The height of each rectangle is 11. 8 by 11. So, let's see if I can shove my answer in here because I'm putting it all into the calculator. 4 square root of 3 times 48 plus 6 times 88. Round to the nearest 10th. So I'm looking at 860.6. And we're looking at square feet. This is an area 2-dimensional. In case you want to see what I put in the calculator. Surface area here, cylinder. I'm just going to do the formula. That's 2 pi RH plus 2 pi r squared. Surface area formula. 2 times pi. The radius is going to be half of 21, which is 10.5. The height is the distance from one base to the other, which is 30, plus 2 pi r squared. It says round to the nearest 10th if necessary. I won't probably have to do that. We'll see. If I leave my answer in terms of pi, I'm going to do 2 times 10.5 times 30 plus 2 times 10.5 squared. 850.5 pi inches squared, or if I put pi in there, which equals 2 1,671.9 inches squared. One of those two answers would be just fine. Okay, surface area of a cone. That is pi RL plus pi R squared. They're hiding some of the information. They didn't give me the radius, but they said the circumference. Circumference is found by doing 2 pi r. If we know the answer is 16 pi, I can solve for the radius. If I divide both sides by 2 pi, that'll cancel out the 2 and the pi. Over here, we cancel out the pi, and we find out the radius is actually 8. So pi times the radius. They've hid the slant height from me as well. But if I know the radius is 8, the height is 15, I can do a quick little Pythagorean Theorem problem. 8 squared plus 15 squared equals c squared. 64 plus 225 equals c squared. So I got 289 is c squared. If I square root both sides, c is 17. That's my slant height. Plus pi times the radius squared. So 8 times 17 plus 8 squared is 200 pi meters squared. We're doing great. Almost done with page 3. Find the volume of each figure. So volume, again, area of the base times the height. If I'm going to call this the base, then I'm going to do 9 times 15 for the base, and then I'm going to call this the height, which is 12. Not a bad problem. 9 times 15 times 12 is 1,620 cubic feet. Volume. Here, volume, 1/3 times the area of the base times the height. The radius is 7. And this is the slant height, so I need the actual height. All right. So if the radius is 7, I'm doing a Pythagorean Theorem problem again. 7 squared plus b squared equals 25 squared. 49 plus b squared equals 625. Minus 49 on both sides. Let's keep this problem separate. I'm at b squared equals 576. And if we square root both sides, b is 24. That's the number I needed for this problem. 24. So, calculator time. Well, I know 1/3 of 24 is 8. I just need to find out what 8 times 49 is, because that's what 7 squared is. So I got 392 pi. Again, we're doing volume, so this is cubic meters. We're on the last page. We're still finding volume here. So volume is still 1/3 area of the base times the height. Square pyramid, so we're going to do 18 times 18 for that square base. And they gave me the height. So nice of them. So 1/3 times 18 squared times 20 gives me a calculated answer of 2,160 cubic feet. Here we're going area of the base times the height. The area of the base will be pi r squared. So pi times the radius is going to be half of 6. The height is going to be 2. Very nice. They didn't hide anything from me. 3 squared is 9. This is going to be 18 pi cubic inches. These can be confusing. The slice of cheese, this round thing is the cheese, is cut from a slice of cheese is cut from a cylinder-shaped cheese as shown. Describe the cross-section. They want to know what is this two-dimensional shape right here. That's a rectangle. Please understand that a cross-section is always going to be a two-dimensional answer, never a three-dimensional. All right, again, this is my favorite part. If you understand the concept, difficult concept that we talked in class, we don't even need these objects. We don't need them. If all of the dimensions of a figure are tripled, if we triple the dimensions, the area is a two-dimensional concept. When we move into surface area, the surface area, we will square, we will say 3 squared or an answer of 9. When we move into volume, it becomes a three-dimensional idea. It's going to be 3 cubed or 27. Notice I did not need the object. That's the best part if you understand the concept really, really well. Again, all dimensions of a figure are half. If the dimensions are multiplied by half, we know what's going to happen to the two-dimensional effect. It's going to be whatever 1/2 squared is, which happens to be 1/4. Volume is going to be affected by 1/2 cubed or 1/8. It's very, very fast if you understand the concept. Otherwise, you have to find the surface area of this object, manipulate the dimensions, and find the surface area again and try and see, what do I have to multiply one surface area, the original one, to get the new one? It's a lot of work. Unless you understand my concept, understand that dimensions, that's one-dimensional concept. Perimeter, one-dimensional. All right, lengths, heights, slant heights, all those things are one-dimensional concepts. When you move into area or surface area, that's a two-dimensional concept. Volume is three-dimensional. If you know how one of these is affected, you should know all of them. If I know that the volume was affected by a factor of 125, you can cube root that. The cube root of 125 is 5. That means all of the one-dimensional effects had to be multiplied by 5. The two-dimensional effects had to be affected by 5 squared, which is 25. This is just an example, not the answer to this problem. I hope that made sense. That was the last page of the review. You guys have almost made it to the end. Don't give up. Keep doing your best, and I'll see you in class.